Hi, this is Cindy. I've put dysrhythmia quizzes and 12-lead quizzes in your mailboxes today. One of the questions that has come up with the EKG refresher and just in general is about Q waves. So I'm just going to talk for a minute about Q waves. So when you're looking at QRSs, when you have your isoelectric line, you'd have your P wave here. Then you have where you'd have your PR segment. And then right as your PR interval ends and your QRS begins, a Q wave is a negative deflection. It's always a negative deflection from your isoelectric line, and it happens before any positive deflection would occur. So here's an example of a small Q wave. And here's an example, isoelectric line, so the end of your PR segment, and then it goes negatively deflected and then positive. That is a large Q wave. So we're going to look at some examples here. When we look at number 1, we have isoelectric line, and then it starts to go downward or negatively deflected as our first waveform. So this complex has a Q wave. Number 2, we have isoelectric line, and at the beginning of our QRS it is positively deflected, so there is not a Q wave. Number 3, we have isoelectric line and our QRS begins to go upward or positively deflected, so again we do not have a Q wave. And number 4, we have isoelectric line and then it goes straight down. So this is an example of a Q wave actually without an R wave. Number 5, we have isoelectric line, then it's negatively deflected and then goes positively deflected, so number 5 does have a Q wave. Number 6, we have isoelectric line, it goes up and then down, so we do not have a Q wave. A Q wave is always the first negative, it's the first waveform if it is negatively deflected. Number 7, we have again the QRS is positively deflected, so we do not have a Q wave, and same thing happens in number 8. So how do we know if it's a pathological versus a normal QRS? And in a normal QRS or a normal Q wave, what you're going to have is you're going to have, again, you're going to have your isoelectric line, your QRS is going to be negatively deflected and then probably positively deflected, and it's going to be short in comparison to the total depth of the QRS, and it's going to be one small box, 0.04 seconds or less in width. A pathologic Q, it also, you have isoelectric, then it's negatively deflected, but the width of it is 0.04 seconds or greater, so a small box or greater, and at least a third the depth of the QRS. And why that is clinically significant is that means that there at some point has been full myocardial, epicardial, endocardial death and scarring, and that part of the heart cannot conduct because of the scar tissue. So we don't see pathologic Qs very often, or nearly as often as we used to, because as you know, when you have somebody that has a STEMI, the first thing we want to do is emergently get them to the cath lab, revascularize that vessel, and then that injured area can actually become ischemic and then completely heal if we get it revascularized. If we have injured tissue that does not get revascularized and it goes from injury to myocardial infarction or death, then that's when you get a pathologic Q. So sometimes you hear physicians may tell a patient that they had a heart attack and they're like, I've never had one before. That's how they can tell us from that pathologic Q. And once you have a pathologic Q, you always have it going forward. So that's why you will see providers go in and look at previous 12 leads. If they have a pathologic Q now, did they have it before? If they had one 6 months ago and that did not have a pathologic Q, but now they do have one, it means that they had an infarct at some time in the last 6 months. It could have been 5 months and 30 days ago. It could have been a week ago. We really don't know. But that pathologic Q shows that we've had that full thickness, myocardial, epicardial, endocardial death. If you have any questions, let me know. Thanks. Bye.